The recording.
Welcome to OpenShift Commons General Community Meeting. My name is Valentina. I'm a Principal Technical Marketing Manager in OpenShift. I had the pleasure today to host this session. Thank you so much, Karina. Please introduce yourself if you are new to this meeting.
I guess I'll go first. My name is Adam Kaplan. I'm a software engineer at Red Hat, and I will be presenting later today. This is not my first OpenShift Commons, but certainly, I think my first one here on Zoom. So happy to be here.
Yeah, welcome, Adam. Anyone else? Okay, so Adam will be doing a presentation in the project Shipwright. So Adam, it's all yours.
Sure. Let me go ahead and share my screen, and I'll be sharing my whole thing for a moment. So hopefully you can see the slide presentation.
Yes.
Okay, excellent. Yes, so thank you for having me. My name is Adam. I'm a software engineer here at Red Hat. I've been at Red Hat for about, say, a little over 6 years now. And for a lot of that time, I have been working on Shipwright, which I'm very happy to present today. And will introduce you to what it is, as well as a little bit of its history, and show you how you can actually use this on OpenShift today. So probably the most important question is, what is Shipwright? That's the reason why you're here or watching this recording. And Shipwright is a framework for building container images on Kubernetes. It's something that we started at Red Hat, but then upstreamed it to the Continuous Delivery Foundation. And it's a way to really use your Kubernetes cluster to build container images so that you don't have to rely on either some other virtual machine or, worst case, developer laptops for building your container images. Just for point of clarification, if your teams are relying on individual developer laptops to produce images that you're running in production, please don't do that. So one of the things that makes Shipwright a great tool for doing this is that we have a dedicated API that is just focused on building container images, which I will show off in a little bit. It consists of 3 core objects: the build object, which defines kind of what you're trying to build; the build run, which is your execution; and then the one that's really innovative and probably the most important part of it is the build strategy API. And the reason we have the build strategy API is it lets us separate how you're building a container image versus the thing that you're actually trying to build. In addition, we have a command line called ship that lets you manage your builds just through the command line, so developers don't need to leave and go to another system to see their builds. It also lets you build from local source code. So that's useful to sort of like narrow that gap between what we sometimes call inner loop development and outer loop development. It also enables potential integrations with other systems like Jenkins, for example. If you install the ship command line in your Jenkins instance, you could use it to then run a build on a Kubernetes cluster that you connect it to. It is powered by Tekton, so we actually use Tekton under the covers to drive and manage the build, but do it in a way that the developer doesn't have to see it. And finally, in terms of how you actually use it, it can be deployed through just the upstream release. We have a YAML payload that you can use to install, or we have an operator that there's a community version that's available on Operator Hub. And we also just announced yesterday, we have a productized Red Hat version of it called Builds for OpenShift. And so I'm going to be showing some of that. You'll see it as Builds for OpenShift, but right now it is all just Shipwright. First off, any questions from folks before I move on?
Hey, how you doing? Um,
Oh,
yeah, so I've heard of Shipwright before. So th this is done to complement Bill, Scopio, all the other Podman, all those container builders, building tools as well, or is this something more for the CD pipeline automation? Um,
I'd say it's probably that first one about enabling build tooling, not necessarily Podman specific, because Podman is a very powerful tool. But when you do Podman build, it actually uses Builda. It actually uses the same code. So we have a build strategy sample upstream where you can use Builda to build the container image, but as well as source to image. So those who are familiar with the S2I tool, we have a strategy that actually we use S2I to wire in a container file that goes to Builda to build your container image. But there's a lot more out there, way more than when we started OpenShift 3. Gosh, I don't know how many years ago, almost a decade at this point. So there's two that I really like to call out that are both in the CNCF as projects. One is Cloud Native Build Packs. And we've actually worked with the community, not my team directly, but other folks at Red Hat have worked with the Paketo community, and they now have build packs that are based on UBI, which is very exciting. That was not an easy feat, and there was a lot of work that went into that, as well as the Co project. This I think started at Google, but it's now fully upstreamed, and that is optimized for building Go container images. And the Shipwright project actually uses Co as part of its release process right now. And I think we also have samples for Kaneko, and yeah, I think those are the main ones that I think we have samples for, or are things that like we actively use.
Adam, there is a question on the chat as well. If you can talk a little more about the recent release from Red Hat on this product.
Yes, I'd be happy to. So yes, builds for OpenShift is we just announced a GA this week. The version 101 is what's out there. So this is actually a GA product that you can use. You might see in the API, if you go into the details, it'll say V1 beta 1, but we are releasing it with Red Hat's GA promise. And it's available on 4.15 and 4.14 for OpenShift, I believe. And we're working to adding more versions of supported OpenShift with subsequent releases.
Perfect. Okay, yeah. Adam, David had more questions. Go ahead.
Oh, so continue. Oh, David, looks like your hand is raised.
Yep.
Yeah. The question I have from a standpoint, can you hear me okay? Okay. The question I was having, what I was asking, I actually asked the question is, so we're looking, from our standpoint as CI/CD pipeline type environment, Tecton, Argo CD, that type of thing. So would Shipwright fill that niche or goal of using a CI/CD pipeline from end to end? And is this software, from a production ready standpoint, meaning that I've got an OpenShift setup right now, can I just drop this into the OpenShift platform that I currently have, or a cluster, and work from there? Or is it like a kind of a beta version? I use quote, air quote, beta version, meaning it's not ready for production yet. Does that make sense, Adam?
Yes.
That was the question.
So in terms of whether or not you can use this on OpenShift, yes, you can. And I will, in a few minutes, I will show you how to do that. In terms of production readiness, so one of the great things about the Shipwright community is that it's been adopted by an actual service. IBM Code Engine is one of the adopters. And so they've been running Shipwright in production for almost 2 years now. And they've contributed a lot to harden the control plane for it and make it scalable for their environment. So we think it's ready. That said, as more people use it, and there's more things that might need to be done in terms of high availability, things like that. Those are features that we will absolutely take in and add to our roadmap for the future so that it meets the needs of our customers.
Thank you. Just like I said, we're looking at trying to, stand something, setting our own OpenShift platform up, and we're trying to find a CI/CD pipeline. That was the question, Adam.
Yep.
To try to figure out.
So I will say about also, I think maybe David, if after the demo, maybe it can once I do the demo, maybe that might help answer some of your questions in terms of how this fits in with like a CI/CD pipeline.
Sounds good. Thank you, Adam.
Any other questions?
Seems we don't have more questions, so yeah, go ahead.
All right. So I'll just go right on ahead and do the demo. I think that might make the most sense to get started. So to get started with Shipwright, you can drop it into OpenShift through Operator Hub. And so there's 2 operators that you need to install. So first, you need to install Red Hat OpenShift pipelines. And then once you have installed OpenShift pipelines, you then install the builds for Red Hat OpenShift operator. Oops. So you can actually see I have the operator already installed. Apologize. If I go to the operator, installed operators, you can see I have these 2 operators on my cluster. One thing that you need to do when you start, in order to actually install Shipwright onto the cluster, is that you need to create this Shipwright build object. It's a pretty small, simple configuration, which tells it where to install Shipwright 2. In this case, the OpenShift builds namespace. This is something that we're probably going to improve in future releases so that you don't have to do this. When you install builds for Red Hat OpenShift, this will be taken care of for you. Then once you have the operator, you can actually get started doing builds. So hopefully folks can now see my command line environment, my VS Code.
Yes, we can.
All right. So one of the things that Shipwright is very good for is it's letting you choose the right tool to build your application. And so to build your application, you have to define a build for it. And so this is what a build object looks like. You tell it where you're getting your source code from. Right now, we only support Git. So you tell it where the code is. In this case, I'm pulling it from SCL or Node.js example. That's a sample Node.js application that is S2I enabled. So to build it, we tell it which strategy to use. And there's 2 flavors. One is build strategy, which is namespace scoped, and cluster build strategy, which is available to the whole cluster. When you install builds for OpenShift, you get 2 build strategies, source to image and builda. And so we're going to start with that source to image strategy. The last thing that you need is really required is the output, which tells it where we're pushing it to. And if you're pushing it to an image stream, you can use the actual address of the internal registry on the cluster to push to it. Through the magic of OpenShift, Shipwright knows how to push to the internal registry. And similarly, with S2I, if you're used to the source build strategy on OpenShift, where you have to define your builder image, you have to do the same thing here. So I am likewise defining using as a parameter the Node.js S2I builder that is also on the internal registry. So we go ahead and create that build. And so I actually hadn't created an image stream for it yet. So this just tells the registry that this image is coming. And once we have the build set up, we can then use the ship command line to start that build. And it's pretty intuitive. You just tell it to run whichever image you have. And then you start following the build. So once we start the build, you see a few things start happening. So first we have the build run starts, it has a status pending. That then creates a Tecton task run. And then that task run in turn creates a pod. And because we are on OpenShift, this is all integrated through the console. You can actually see this as well. So I'll go ahead to the builds part of the console, and you see we have this new section called Shipwright builds. And we're looking at all projects. So I'll just narrow this down to the one that I'm doing the demo in. And you can see we have the build here. It's pushing out to the Node.js example image stream, and it knows that it's pushing to that image stream. And you can see the most recent run. When you drill into the build, you can see the details of it. You can see the annotations, where the source is coming from, the builder image that it's using, the output, and the build strategy. And you can likewise see the build runs for it. And when you drill into the build runs, you can get access to the logs right away through the console. And so you can see here right now, we're in the build part of the S2I strategy. So we've generated our Docker file. Now we're going to feed it to Builda, and Builda is now pulling the image and building it. And if I jump over to the command line where I'm following it, you can see the same thing. Oh, and we can see we have a few issues coming up. For example, we have a dependency that is deprecated and might no longer be supported. Oh no. And you can see now we're at the stage where the build is done. And now it's going to push to the internal registry. And you can see the logs are similarly reflected here. We've had a successful build. And so because of the way Shipwright works, you're not necessarily, even engineering teams aren't locked into just using one build strategy. As long as you have a build strategy, you can use it in your build. So I'm going to switch over, and this is a new build that I'm defining, but instead of using S2I, I'm going to use Builda, and it's a slightly different Git repo. Because in order to use Builda, you need to have some sort of either Docker file or container file. And by default, the strategy will look for a Docker file at the root of the repository. Or in the case here, there's a context directory that we're telling where the application code lives. And so similarly, once we've created the build, we have to run it. The command line makes it really easy to do. And you can see we're already on our way. We've started the build. We're pulling the container image for it. We go back to the console. You can see now we have the Builda Node.js build. You can see the runs for it. And once again, you can drill into the logs for it. One other thing I want to point out is that you don't just have to be on the admin part of the OpenShift console to see this. You can jump over to the developer perspective, and the Shipwright is also integrated as well. So we have, if you click on builds, it's now says we have build configs as well as Shipwright builds. It recognizes, sorry, that we do have Shipwright installed. You can see we have, just like before, the S2I build. We have our Node.js build for Builda, which is currently running. And just as before, we can drill in and get the logs. Any questions for folks while we're waiting for the build to complete?
This is great, by the way. I really love that you show us also the developer perspective. So there is a question actually on the chat from Benjamin. Can we do confidential containers?
Confidential containers. Is that a Kata containers? Sometimes I get confused about some of those specific technologies.
Yeah, let's see if Ben wants to add more context as well. Any other questions in the meantime about the demo? This is great, by the way, Adam.
So, yep.
Yes, I think Kata does have a version of the confidential containers that is being done, but I think there's a I mean I've seen they have a way of doing it, and they're, I guess, still in development, but I thought there was another way that Red Hat was supporting confidential containers.
Okay. I'll be honest with you, I'll have to look into that. I don't have an immediate answer.
Yeah, we can connect with you after the session.
Yeah.
David, so you were asking before about Shipwright and what the project is doing. And after the demo, do you have any other questions or comments?
Nope. I'm just looking, looking to see what Shipwright can do. And if Adam wants to hang out after the meeting and the, recording, going into more detail with Shipwright or something to that nature. That's up to him.
Yeah. Any other question? Yeah, Adam, we probably can do that. Any other questions?
I know my first time hearing about Shipwright was with the OKD working group, and using it to help, become part of the build process for OKD.
Yeah, I'm actually glad you brought up the OKD working group and the community there. So they actually did a lot with Shipwright to drive their multi-arch build strategy, and it's there's a lot of engineering that went into it, and I think so we just started that collaboration with the OKD community to learn from them and incorporate their experiences, particularly around multi-arch with the Shipwright. So, and we can bring that into Shipwright. Multi-arch is a really challenging thing to do, especially in CID.
Are you talking? Because we're not getting nothing.
Can you hear me?
Yeah, I can hear you fine.
Oh, you can hear me? Okay.
Yes,
Nothing.
yes. Yeah, so maybe do you want to join again? I don't know if it was David who's talking. I can hear you, Adam.
Okay. So yes, you can hear me? Can you hear me?
I can.
Okay.
I don't know if, yeah.
Okay, so David is just the one who you hear from.
Yeah.
And so, Adam, the multi-arch with OKD, that's not in OpenShift yet? That's something that maybe down the road will be there, or?
It's something that we definitely want to add to the roadmap. So it's one of those where, because it's a build strategy, you could try and copy what they did in OKD for yourself. I'd actually like to show off a kind of an example of that. I've got another demo that I'd like to do. But if you look at what OKD did, it's not exactly easy to maintain. And so we'd like to have something that is a cleaner experience. So is it okay if I do one more quick demo? Because this one I think folks will get a lot out of.
Yes,
Yeah.
absolutely.
All right.
Yes.
All right. So so one of the things that Shipwright has, and this is actually something that build configs does not have, is that you can add a persistent volume to your build. And that is really useful for things like having a dependency cache. So to get started, I'm going to create a little PVC for myself. This is running on Rosa. So the CSI driver is going to create, I think it's an EBS volume, and it'll do it dynamically. And so as long as that PVC exists, that'll stay there. And one of the things that, because of the build strategy APIs, that you can define your own and use it kind of however you please. You could use the cluster build strategy. I would just say the ones that come with the operator, you can't change. The operator will most likely revert it. But you can either add your own at the cluster level or at the namespace level. And so I'm actually going to do that here. And let me actually show it off. This is the build a cache strategy. And so you can see what this looks like in the full YAML. I've just copied the build strategy that comes with builds for OpenShift. And the thing that I'm adding to it is this volume mounts, where I'm adding a place where we're mounting data into the container for the cache, as well as the definition of the volumes. And an important thing about the volumes when you're defining them with a build strategy is this field we have called overridable. This makes it easier to share a build strategy that is using a volume, because not every environment will support persistent volumes in the same way. So having an empty directory is usually a safe default, because every Kubernetes is going to support the empty dir, which is temporary storage on the node that the pod can use. Once we have that volume, we can then say where it gets mounted to and where the data comes from. So since we're using builda, I'm going to mount this to verlib containers. And this directory is where builda by default looks for container image layers, and also will write container image layers too. And so on the volume itself, I'm going to define like a subpath for it, where I'm going to put these container image layers. That's because like in a real world use case, you'll probably want to have caches for things that aren't just container image layers. If you're doing a Node.js build, all the node modules, you'll want to have caches for that. If you're doing like a Java Spring Boot application, all of your Maven dependencies, you'll want those to probably be in a cache as well. So the beauty of the build strategy API is that if you know that, say, you're doing a Node.js or a Java build, and you want to like optimize for that kind of application, you can go ahead and do that and and create your own kind of cache that you can wire into builda. And so I'll have the respective build. Just try and get through this quickly. And then we'll run it. And what I'm going to do is I'm going to time this. And if you saw before, the builds will take probably between 2 or 3 minutes to start with the fresh build. And just as before, I also want to show off the console integration here. You saw before I created a new build definition. This is now our build Node.js cache one. And you can see on the console as well in the strategy, it's no longer a cluster build strategy. It's just the build strategy called build cache. And you can drill in to see the YAML for it. You can see this was, since it was kubectl or OC that applied it, the annotations for it. And going back to the build, you can see we again can drill into the build run, see that it's running, look at the logs. And here you can see that we're pulling the image. And it can take a little bit of time. Any questions while we're waiting about build strategies?
Which one's easier to implement, Builda or the other one?
In terms of source to image, you mean?
Right.
So with source to image, you don't need to write a Docker file. And so if your team has never written Docker files before, and in particular is kind of using more or less standard language tooling for their application, S2I would probably be a better fit. It's certainly faster to adopt. I think the challenge with any kind of application as it grows in complexity is that you start seeing different languages and tools mix and match. And that's where it gets much harder to use source to image.
In relation to Shipwright, correct?
So source to image is used with Shipwright. I think that's
Okay.
an important thing to kind of think about, is that source to image is a tool that Shipwright can use to drive the build, but it's not the only tool that you can use. We're today supporting Builda and source to image out of the box, but things like cloud native build packs is something that we are actually actively looking into through that Paketo community engagement that I mentioned earlier.
Mm-hmm.
And there's others that are out there as well. Kaneko is another one that developers use, as well as Docker's own build kit or BuildX. Anything that can be run inside of a container can be used by Shipwright. So I'd like to jump back to the build, if that's okay. So you can see that this first build, it took a little over 3 minutes. But now that I have a cache, let's see if this actually runs a little faster. And so we're going to have the same thing where the build is going to run. It's currently in, we got to wait for the build to actually start. You can even drill down to the pod and see what this looks like. You can see there's a lot of Tecton internals in terms of its pod volumes, but the one that's mounted in, you can see here, is from Bearloop containers. right? We can see we're actually almost done. And I do want to point out something in the log. And you can see here, if you noticed before in the first build, you saw the output from Builda saying that it was pulling some blobs and writing them. We didn't have to do that here. That was skipped because those layers were all stored locally. And so the only thing we needed to do then was push. And you can see over here now, that second build only took a little over a minute and a half. So we were actually able to cut the build time in half here. This is a relatively simple application. You probably won't see a 50% speed up in the real world. Especially if you're doing like a Spring Boot app that needs to compile jars and such. But nonetheless, those steps of pulling container images and doing everything effectively fresh, that was able to be skipped here because we had that cache. Any other questions?
Adam, I assume, I guess since it's just been released, some labs and future stuff will be coming on where people can go to get started if they want to begin to use this tool.
Yes. Yes, I think that that content should be coming hopefully over the next few months. Any other questions? Let me jump back to the console view.
What type of environment do you need if you wanted to try to test out that multi-arch feature?
So I'd be honest, I have to look at what the OKD community did in terms of orchestrating multi-arch. I think one of the things that I think is probably the easier thing that we want to drive towards is having, if you have multi-arch worker nodes, being able to schedule and orchestrate it. I want to be clear that this is something that right now you'd be kind of effectively hacking inside of a build strategy. That's long term, that's not ideal. Something that we want to move the community towards. And the community has been thinking about this is like, how do we approach multi-arch? Because there's actually a lot of different ways you can tackle that problem. And having, worker nodes of different architectures is one approach.
Adam, is it possible to share any of this content with the audience? Maybe on the Slack, like, I don't know, the sample YAML files that you created.
Yeah. So there are actually some samples already on the Shipwright website, and actually some of the samples that I do have, I'll want to ensure that we're having those in the Shipwright website. I also, all of this code that's here, most of it I put on my own personal GitHub, and I'd be happy to share that as well.
Fantastic. That's great. Any other questions? This was great, Adam. I really enjoyed learning more about Shipwright. So thank you so much.
Great.
Any other questions or comments for Adam? Okay. So Adam, also, I think the slides, if we could have the slides, would be great as well.
Yes. I can share, probably be easiest if I share a PDF of that, or the Google slide deck.
Yeah.
The challenge is not this is right now on my Red Hat one, and it sometimes
Maybe a
it's not,
PDF then.
yeah, PDF is probably easier to do.
Great. Okay. Well, thank you so much, everyone, for joining us today. Thank you so much, Adam, for the amazing demo. So what we will be doing next week is Cell Playground with Kevin from GitHub Cloud. So we are looking forward to seeing you next week. Anything else? Karina, do you want to add something else?
No, this was great. Thank you all. And we'll see
Great.
you next week. Awesome.
See you next
Thanks
week.
so much, everyone.
Thank you.